Hey guys, welcome back to the OpenTK Basics tutorial series. My name is Sil, and in this part we're going to be talking about using immediate mode as well as better methods of drawing stuff to OpenTK. We're also going to be loading in a texture. I will be going a little bit fast through that since I have covered loading in a texture in my OpenTK platform tutorial series, but I want to make sure that I mention a lot of the stuff that needs to be cleared up about why we do the stuff to load the texture. Anyways, but the first thing we want to do for loading a texture, we're going to do that first, and then we're going to draw stuff. Well, you know what? No, we'll go ahead and draw an untextured rectangle first. So we'll go ahead and use immediate mode. Now, there's two different ways of drawing stuff in OpenTK/OpenGL. There's immediate mode, which is deprecated and kind of old, but it's really, really easy and easy to understand. So most beginner tutorials that you learn or that you see will be on how to use immediate mode to draw stuff, and it can do most of anything you want. However, it's really slow compared to the other ways of drawing stuff, and I can't at the moment think of the name for the other mode, but basically what most common or new games or anything that wants performance does is it does indirect mode or whatever you call it, where it passes arrays and data to the graphics card and then tells it to draw it on basically on its own time, even though it is when we tell it to draw it. And that way it can optimize and run a whole lot faster, and we don't have to pass a ton of data every frame and stuff like that. So we'll be getting into that pretty soon. Probably not this tutorial since we got to load in a texture. So we're going to go ahead and do immediate mode. And the way that we do that is we say GL.Begin and we do primitive type. You can also do begin mode, but begin mode is like the older depreciated version of it. So primitive type is what it wants you to use, and we'll do primitive type dot. We'll go ahead and do triangles because triangles is kind of a classic thing. And then we also need to call GL.End right there. And then in between these, we can tell OpenGL to draw vertices. And right now, the default coordinate system on the screen is 0, 0 as the center. 1 on the y-axis is the 1 on the y-axis is the top of the screen. Or -1 on the y-axis is the bottom. -1 is the left on the x-axis, and 1 on the right x-axis. Anyway, so we're going to go ahead and do GL.vertex3, or vertex2, sorry, since we're doing a 2D thing at the moment. And vertex2 simply just says, hey, draw a vertex at this position. So we're going to do vertex2, and we'll do 1, 0. And that's saying, well, I'll do 0, 0 first. And we're going to do a triangle here, so we're going to go ahead and do 1, 1 for the bottom right, or sorry, it's going to be the top right. And then we'll do like -1, 1. And now that we've said 3 different vertices, it'll go ahead and make a primitive and draw that primitive to the stream since we're in triangle mode. If we're in quad mode, we'd have to draw 4 vertices for it to draw anything. Anyways, we'll go ahead and run that here, and you'll see that we got a white triangle. We haven't defined a color, a texture, or anything else about it, just a white triangle. So what we can do is we can define the color really easy. We can do GL.color3, or we can do color 4 if we want alpha. We'll do GL.color3, we'll do color.red, something like that. And you'll see that it turned it red. We can also do different colors for each vertex if we change the color in between. One thing to know is that these other calls, like color3 is simply setting a variable. It won't draw a vertex for us. So we can, like for example, we can set the color here, draw 2 vertices, set another color, like green, and then only the third vertex will be green, but the other 2 will be red. So vertex 2 is kind of what says, hey, use the current settings that we've passed to you and draw a vertex here. So just kind of one thing to note. Now, if we do want like alpha, let's say we want color 4, and we would do color.fromRGB, and we'll do like 255, 255, 255. Oh, sorry, the alpha comes at the beginning here. But for the alpha, we do like something like 128, right? We want it to be semi-transparent, and so we'd expect to see the blue background of it, but in fact, we just see white. And the reason for that is we haven't told OpenGL that we want blending or how to do it, and that's kind of a common theme with using OpenGL is that you have to tell it what you're going to do and what to do with it. So what we want to do is we want to enable the blending. So we can either do this at the top or we can do it in our draw function. It depends on um, how your code's set up. For example, like I've had problems with wanting to default stuff to the top and setting variables there and just expecting them to carry over to my draw function, but then like I'll have different components of my game that change those variables and don't change them back, and so by the time it gets to my draw function I forgot to set it again. So oftentimes I've been tending towards enabling and disabling stuff just before I actually draw that stuff to make sure that it is enabled or disabled right there. And that's just kind of because code structure and whatnot, and just making sure that all the variables that I need set to draw stuff correctly in this draw function isn't going to be messed up by another draw function by a different part of the game. So we're going to go ahead and do it here. We're going to do GL.Enable. And enable is a really common thing for enabling different features in OpenGL. A lot of them default to being disabled, so you want to make sure that you enable them. And we're going to do enable cap. That's just the enum that has all of the different features here. You can look through them and read up on each one of those, and there's a corresponding OpenGL, like C++ DLL enum for it. But what we want to do is we want to do blend. And that tells it we want blend, but we haven't told it how to yet, and so it still won't work. So you'd think that this line would say, hey, enable blending, and would automatically do it, but it doesn't, and that's just kind of how it is. So what we have to do is we have to actually go ahead and tell it how to blend, or how to blend two different fragments. So what we do is we do gl.blendfunc, and this is where we set the blending function. So how it combines two different pixels. For the blending factor source, we do blending factor source.source alpha, and that says that we want to use the alpha from the source, either color or image. And then we'll do blending factor destination, and we'll do 1 minus source alpha. Gosh. There we are. And now if we run this, you'll see that we got blending, and it's a little bit hard to see. Not a great version of blending. If we go ahead and make a color.red here. There you go. You can see that it's more, it's blending more there. If we go ahead and do 0 alpha there, it'll blend from fully opaque to fully transparent on that pixel. So that's kind of cool. We got blending put in, and it works just fine. What we want to do now is go ahead and add our texture2D class really fast. So we're going to go ahead and right click on our project, do add class. I'm going to do texture2D. And our texture2D class is actually going to struct, and it's a really simple struct. All it's going to hold is public int id. Well, we'll actually do private int id, and we'll do private. We'll do vector2, yeah. Vector2 is an OpenTK thing, so you want to be using OpenTK, and we'll do size. And then we want to make public access for those, so we'll do public int id. And we'll do get return ID public vector2 size get return size, and we'll go ahead and make a float. Actually, you know what? This is a point. We're gonna go ahead and make this a point. Nah, it's easier. Never mind. We'll go ahead and do int width. We'll do get return int size.x, and hopefully this makes a bit of sense. I haven't really explained what I'm doing here, but just making a basic class to hold some of the common variables about our texture2D, and just so that we can know that a variable that we're holding that is in our code is a texture2D, not just an integer, because OpenGL passes back an integer ID for our use, so that we can know that we can tell it which texture we want to use once we've generated it and passed the data to it. But that's kind of confusing if you don't have like a wrapper for it, because then you have a lot of integers and you don't know which ones are textures, which ones are actual integers, and which ones are whatever else. So anyways, we're going to do a constructor for this. We'll do public texture2D, we'll do int id and vector2 size. We'll do this.id equals id, this.size equals size. It's pretty straightforward, just a couple variables in a struct. with some accessors. Now we're going to go ahead and make what I like to call the ContentPipe class. It doesn't do a lot for us, but it is fairly more readable to put the function here. It's going to be a public static function so that we can load stuff from anywhere. And it's going to return a texture 2D, and we're going to call it load texture. And we're going to go ahead and ask for a string file name. We'll call it FilePath actually. And then we're going to ask for a bool, and we'll ask if we want it to be pixelated, and we'll set a default value to false. And by pixelated, I mean the sampling type of the texture 2D, if it'll be linear or nearest neighbor. Anyways, we're going to default the file path into a folder that we're going to make in our project, and I like to call this folder content. Whoops, go ahead and respell that. This is just nice so that when we export our game, we have our exe, and then right next to that exe will be a folder with content, and that's where all our content will be, rather than having all of our content right next to the exe, which looks kind of bad. So we're going to go ahead and default file path there by going file path equals content plus, oh gosh dang it, file path. And we're going to go ahead and make a note of that by typing three forward slashes there. It'll automatically make a summary for this function for Visual Studios so that IntelliSense can know about it. And we'll go ahead on the file path variable here. We'll do defaults to content, just so that we don't forget that, just so we don't forget that we don't have to pass it the content folder in our file path. Anyways, and then we're going to do if file, and we're going to be using system.io right there at the top. File.exists, and we'll do file path. So basically we just want to add a handler to make sure that the file does exist. If it doesn't exist, we'll do throw new exception file does not exist at here, and we'll call it pass the file path there. So just so that it throws an exception, it doesn't continue. Oh, what does it not like about that? Oh yeah, hold on. I forgot I'm not writing the console here. Do our own stuff. There we are. Anyways, so just an exception there to make sure that we actually have a file that exists there. And then what we're going to do is we're going to do bitmap. And bitmap is going to be system.drawing. So we're going to go ahead and using system.drawing at the top. And BMP equals new bitmap, and it's going to ask for either a stream, an image, or a file name. We're going to do file name. We're going to do file path. Oops. Path. And then we're going to do bitmap data. And again, we're going to be using system.drawing.imaging for bitmap data. And we'll do data equals bmt.lockbits. And we're going to do new rectangle. We'll do 0, 0, and we'll do bmp.width, bmp.height, image lock mode dot read only, pixel format dot, I believe we want to do format 32 bp RGB. There we are. And that's basically just telling the bitmap that it needs to lock its bits in memory, so the bytes that hold the actual data of the image need to be locked so that we can read and pass them to OpenGL, and this bitmap data function kind of holds a reference to it. Pixel format's telling it what type of pixel format it should provide to us, I believe. I'm not quite sure about that. If somebody knows a little bit better on that subject, you might be able to let me know. And then we're just saying that we want to read from it. Now what we want to do before we start actually passing data to OpenGL, we want to tell it that it needs to generate a texture or a place to put that data. So we're going to hold the ID variable here shortly and put it into our text2D class a little bit later. We do GL.GenTexture. Oh, hold on, I got to using graphics at OpenGL. Using OpenTK Graphics to OpenGL. And then GL.GenBuffer. Sorry, GenTexture. We'll be using GenBuffer later. There we are. So basically it's telling OpenGL that it needs to generate a texture. And what do I have wrong here? Okay, yeah. So basically, since OpenTK and System.Drawing both have a pixel format, we need to specify which one. Kind of annoying. I do use a lot of using statements, and that can be kind of a problem when they do relatively the same stuff, like when they have the same class names. I find this to be easier than not having the using statements and typing, OpenTK every single time. But if you prefer not having using statements, you can go ahead and type out OpenTK dot whatever. Anyways, now what we want to do is we want to do um, GL.Bind texture. We want to say, hey, we're going to bind this texture to the texture 2D, and we're going to pass it that ID that we just generated. So basically, we're going to be working on this texture that you just generated. This is a common thing that we do. We also bind it when we want to say that's what we're drawing with at the moment. And then what we want to do is we want to actually pass the bits to it so that it can insert that into the buffer or the texture that it created. So we do that by doing gl.textImage2D. And this is kind of the all-important function. For text target, we do text target 2D. And for the level, we'll do 0 because we're not putting it in any of the mip-map levels. I believe that's what it's referencing there. I'm not sure if it says. Yeah, it's mip-maps level detail. So it'll generate mip-maps for us. Or it won't. I think we tell it not to. But anyways, we're just working with one layer. No bitmaps at the moment. We're passing that data that we loaded into the highest bitmap, which is 0. Pixel internal format, we'll do pixel internal format.rgba. And then for the width and height, we'll do bmp.width, bmp.height. For the border, we'll do 0. Never actually used the border. I'm not sure exactly what it does. And then we'll do BGRA. Not sure why it's in a different order there. And then pixel type we'll do, I think it's unsigned byte. And for the endpointer pixels, we do BMP data. Sorry, data. I call it data in this one. Dot scan 0. And scan 0 is basically that top layer that it loaded in, or basically just a pointer to the beginning of the data so that OpenGL can step through all that data and add it to its own place where it needs to store it to render stuff. And there you are. Now we passed it, so what we need to do is we need to release those bits. So we're going to do bmp.unlockBits, and we'll pass it data, so it knows what bits to unlock. And now that we got the image passed and everything, we want to make sure that we set a couple variables on that image for OpenGL so that it knows how to handle that. And this is where that pixelated variable comes in. So what we'll do is we'll do gl.textParameter, texture targets of texture 2D, texture parameter name dot texture min filter, and we'll do two different things depending on this pixelated boolean here. If you haven't seen this before, you can do pixelated question mark, and we'll do, we got to convert it to an int because it's asking for an int. We'll do texture min filter dot nearest, or, and we'll convert it to an int again, texture min filter dot linear. We'll go ahead and clean this up just a bit. If you haven't seen this question mark colon thing before, basically it's like a compact if statement on this one line. I like doing this. It can be kind of confusing sometimes, but I feel like this is a good situation for it. Basically, if pixelated is true, this will go in its place. If pixelated is false, the second thing will go in its place. So just a really compact if-else statement. But these texture min filters are just enums created by OpenTK to reference the different types of texture min filters. And since we're setting a generic parameter with OpenGL, we need to convert it to an int, which it'll know that it's a texture min filter because we're telling it it's a texture min filter variable. So basically, you can set a lot of different variables on the texture by doing the same exact function and just doing a different texture parameter name, and it'll set the corresponding parameter. Anyways, we need to also do the mag filter here, so we'll copy this line and we'll do mag, and it'll work with the texture min filter integers of enums and whatnot, but we'll just make that clear by making it mag filter enum rather than the min filter enum. And now that we've done pretty much everything that we need to do, we're going to go ahead and pass back a texture. So we're going to do return new texture 2D, and we're going to pass it that ID that we generated before. And then for the size, we're going to do bmp.width and bmp.height. And that'll go ahead and, oh, hold on, what did I do wrong? Oops, forgot that I had made it a vector2 input, so we'll do new vector2. There we are. Now we can go ahead back to our game here, and we can add a texture 2D variable. We'll call it texture. And then in our load function, we can go ahead and load it by going texture equals ContentPipe load texture. And for the file path, we do actually add a texture to our content folder here. So we're going to do add existing item. I'm going to go ahead and use this little penguin.png that I made so that we have a transparency test and that kind of stuff. One thing to note, I have noted this in the other tutorial, but I'll note it here. You do have to set the properties on it so that it copies to the output directory. So we'll set the build action to none and copy fnewer or copy always. That way it actually copies it rather than compiles it into the exe so that we can read it at runtime. So then we're going to do penguin2.png. There we are, and so that'll load and make a texture 2D and pass it back to us so that we can hold it. And really all it is just an ID that we pass to OpenGL to tell it which texture that it has that we want us to draw with. And now what we do is before drawing here, we can do GL.Bind texture, texture target.texture 2D, and we'll do texture.id there, because all the OpenGL cares about is the ID, not the texture class that we created. The only reason that the texture class is really useful is so that now that even though we only really have the ID, we also know what size it is, and we know it's a texture 2D, so it's really useful. And now if we go ahead and run this, two things are wrong that will make it not have a texture. One, we haven't defined texture coordinates for each vertex, which we can do by doing gl.textcoord2. We'll do 0, 0, and texture coordinates are defined from 0 to 1. So the left of the image is 0, right of the image is 1, top of the image is 0, bottom of the image is 1, no matter the size of the image. So always should be between 0 and 1. It may be a little bit counterintuitive at the moment, but it's actually a lot more useful when you actually start getting into it. So we're going to go ahead and add a texture 2D, or a textcoord2 to each of these, and we'll do like, what do we got here? Yeah, we'll just do 1 and 1, 1. Something like that. It'll probably be a little bit weird skewed. But if we go ahead and run this now, it still won't do anything. And that's again because we haven't told OpenGL that we want a texture. So what we do is we do gl.enable, enablecap.texture2D. And now that we've done that, now that we've said that we want it, and we've loaded it in, and we've passed it to it, and we've enabled it, and then we've defined which part of it we want to draw, now it'll draw it. And we got a very skewed penguin. So yeah, it's pretty straightforward from now. Once you got all of that stuff set up, it's pretty easy to load in multiple textures, draw different ones, bind different ones, that kind of stuff. So hopefully that helped you guys with that. And in the next tutorial, we'll hopefully be looking at not using immediate draw and actually making vertex buffer objects and index buffer objects and that kind of stuff. So hope to see you guys there. Bye.